right, go ahead and put your standards that we're working on at the top of your paper, MD3 and MD4. Both of these standards are talking about graphs, whether it's picture graph, bar graph, line plot, and then measurement. Mostly when we're doing the measurement, it's with the line plots. Okay? If you go to the bottom of your sheet, you've got your objective for today. I can interpret measurement from data from various line plots. That just means I can look at these line plots and I can understand the data that is on the line plot, and then I can answer questions about it. Right? All right, so let's go back up and look at question 1. Coach Harris measures the heights of the children on his 3rd grade basketball team in inches. The heights are shown on the line plot below. Now, height means just how tall they are. Okay? So look at your title. When somebody's reading a line plot, you got to give it a title so that whoever's looking at the data or the information knows what they're looking at. So if I was just to look at this line plot, I would know that this is talking about how tall children are on this basketball team. Heights of children on the 3rd grade basketball team. Well, if I look down here, I know that my scale is the actual height. I see that this looks a lot like a number line. Okay? 51, 51 and a half, 52 inches, 52 and a half inches, 53 inches, 53 and a half inches, 54, 54 and a half, and 55. I also can see my key over here tells me that I'm counting by 1 because 1x stands for just one child. Okay? All right, so let's answer some questions about it. A, how many children are on the team and how do you know? Good question. How are we going to get a total number of children, Peyton, on this team? You got to add all those X's together. Do it. Raise your hand when you think you have a total. What'd you get, Alyssa? 15. All right, let's check her. 1, 2, nothing there. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 children on the team. And how do you know? Well, I know I have to add all those X's together. It's hard to see, isn't it? All right, Williams. The next one says, how many children are less than 53 inches tall? Okay, so if this was mine, I'd find some piece of paper or my hand or something. I'd cover up everything 53 and above because it only wanted to know how tall or how many children are less than 53 inches. So what you got, Williams? Yep, let's look. 1, 2, 3, 4, 5, 6. 6 children are less than 53 inches tall. Now look at the next one. It's kind of a thinker question. Coach Harris says that the most common height, so the height that shows up the most often for the children on his team is 53 and a half inches. So he's looking right here. Okay. Is he right? And explain your answer. He says that 53 and a half is the most common, or that it shows up the most. Is he correct? Hannah?
No, because is 52 people with 3, and there's 53 and a half with 3.
Absolutely right. There are 3 children that are 52 inches, and there are 3 children that are 53 and a half inches. So where it says, is he correct? No. 3 children are 52, and I'm going to use a symbol for inches, and 3 children are 53 and a half inches. Okay? So you got to be careful with that. If there had been 4 right here, then he would have been right. Okay? But because those two are equal, you can't say that that 53 and a half is the most common. Three children are 52 inches and 3 children are 53 and a half inches. So no, he was not quite right. Well, Coach Harris also says that the player who does the tip-off in the beginning of the game has to be at least 54 inches tall. How many children could do the tip-off? Now, Miss Edwards knows nothing about basketball. What is a tip-off? What's a tip-off, Kalia?
When they have to go in the middle of the court and
they hit that ball. Okay, I got you. Gotcha. All right. So, in order to be able to do the tip-off right before the game, you have to be at least 54 inches. So, if this was mine, I'd just cover up everything before 54 inches. And how many children could do that, Athena? How many children would qualify to be able to do that tip-off? If you have to be at least 54 inches, how many children could do the tip-off? Help her out, Ben.
4.
Yeah, 4 of them. So there's the 54. So there's 1, 2, 3, 4. 4 children could do the tip-off. Okay? Being able to read these line plots and just answer these various questions about it. Okay, look at the back. Before we even read the questions, what are we looking at? Length of worms. Okay? So if you look on the bottom, your scale is representing the actual inches of the worms, how long they were, because inches measures length. Okay? You have to look at your key and know what you're counting by. What does each X represent? 1. Now be careful. I kind of wish that they had done a different number here, because it's not always going to be 1. Sometimes they might make you count by 2s or 3s or 4s, just whatever. Always look at that key so you'll know what you're counting by. Okay? Alright, so let's look at number 2. Miss Vernier's class is studying worms. The length, or how long, of the length of the worms in inches are shown in the line plot below. So in order to make a line plot, you draw a number line. Okay? You got to have some kind of scale. This scale happens to be in inches. 3, 3 1/4, 3 2/4, 3 3/4, 4. 4 1/4, 4 2/4, 4 3/4, 5. What does that look like that we did yesterday? Tell me, Claire.
It looks like kind of the same.
Think about what we did yesterday. What were we using yesterday? Yeah, the measure. What were we measuring with, Peyton? Yeah, we were using a ruler. So basically, they've taken the information off of a ruler, because yesterday we measured to the nearest 1/4 inch, 1/2 inch, and whole number, right, the whole inch. So that's basically what this is. This is just a section of that ruler. What did we say 2/4 was equivalent to? Tell me, Peyton. 1/2. So this would also be 3 1/2, and you can write that down there. This would be what?
4 1/2.
4 1/2, because we know that the fractions 2/4 and 1/2 are equivalent. And we talked about that yesterday, Max. Okay? Alright, so now that we've kind of analyzed the line plot and looked at the data on there, let's answer some questions. How many worms did the class measure? And how do you know? What are we going to do, Max, to find a total of how many worms they measured?
Add all the X's.
Yeah, add all the X's. Take a minute and do that. Raise your hand when you think you have it. Need a total number of worms. What you got, Madison?
30.
Yep. So we could say the class measured 30 worms. The class measured 30 worms. Don't forget about restating your questions in math now. Those people that are going to be grading your milestones, when you come to questions like this where you have to write something out, put those words there. They want to see that. They want to see that you've actually read that question and you can turn it around and make a statement from it.
So the ones on the bottom are just like a rule.
What now? These numbers right here? On this one, yes. Okay, because we're talking about length, so it's basically coming straight off that ruler we had yesterday. Okay. All right, B. Kara says that there are more worms that are 3 3/4 inches long. So I'm looking at 3 3/4. Then there are 3 2/4 and 4 1/4. Ooh, a lot of information in this one. Is she right? And explain your answer. Well, I'm going to do this. I'm just going to put a light circle around 3 3/4 because I know I have to look at those. How many worms were this long? How many worms were this long, Audrey? How many worms were 3 3/4 inches long? Alright, I'm going to put a little 6 up here just so I won't forget. But now I have to look at 3 2/4 or 3 1/2 and 4 1/4 combined. So what does that tell me right there? What do I have to do, Alyssa? You got to add. So let's look at 3 2/4. Okay. And how many are 3 2/4, Johnson? There's 4 that are 3 2/4, so I'm just going to make me some notes down here. And then I have to look at 4 1/4. Athena, how many are 4 1/4? Find 4 1/4 and look at the plots above it. How many worms are 4 1/4 inches long? 4 of them. Now, I have to combine those, and you've already said to combine, you have to add. So how many is 4 plus 4? 8. All right, so let's go back and think about this. There's 8 of these, and there's 6 of these. She says that there are more that are 3 3/4 than these two combined. Is she correct? No, she is not correct. So we could say there are more worms that are 3 2/4 and 4 1/4 inches, put your inch sign, combined. And we know that because we added these and we saw that there's 8 of these and only 6 of these. And we know that 8 is greater than 6. Right? Just depends on how many is plotted above it. You have to look at that line plot. You have to look at that key so you know what you're counting by. Alright, and C. Madeline finds a worm hiding under a leaf. She measures it, and it is 4 3/4 inches long. Plot, so we've got to go back up and put an X somewhere, the length of the worm on the line plot. Where are we going to put it? 4 3/4. Poor little thing. Okay, so that's all you do on that one. You had to go back and find 4 3/4 and plot it. Now, instead of having, what did we say, 30 worms, how many really were there? 31, because you got to add that other one back in. Okay? And that's it. That's looking at line plots, looking at bar graphs, interpreting, analyzing that data, getting the information from it, and then just answering whatever questions they throw at you. But y'all, if you don't read those questions carefully, you're not going to be able to answer the questions right. You've got to look at all the clues in those questions to see what they really want you to answer. Okay? All right, put that up. Get everything cleaned and packed up.